So today we're going to be talking about, this is under 3.6, quadratic keywords and word problems. Okay? That's what we're talking about today. First thing is, you can't really talk about, let me focus this a bit. There we go. You can't really talk about word problems until you understand all the keyword aspects of a, well, quadratic. You've done all the calculation side of things. Now it's time to apply it to the real world. Okay? And there's really only one area of massive importance that this really applies to, as far as you're concerned, and that is physics. Now, don't worry, we're not going to talk about anything crazy in physics. We're not going to get to pre-calculus or calculus levels. That stuff's nuts. We're just going to talk about the bare bone basic of identifying each part and using it. So, naturally, you already know most of this stuff, but we will always address and deal with these equations in the form of f of x, ax squared plus bx plus c when it comes to word problems. You will very rarely, if not at all, see a quadratic in vertex form when resulting to a real-world scenario. Yes. Yes. Yep. All right. But it doesn't really apply to real-world scenario. Okay. Now, obviously, we have, this is the y coordinate, and x is all the way down here. We're just going to label this up real quick. Okay. Or the y-axis and the x-axis. There we go. Axis.
Isn't it an axis?
Yeah, axis. I need to move that y to the other side. It looks like it's being multiplied by, shh. Looks like it's being multiplied by the entire thing.
It's like
Oh, come on. Oh, this finally ran out of whiteout? I think it finally ran out of whiteout.
Oh boy.
Yep. I do, but I'll get it later. All right, so, and this, of course, is the y-axis. Okay. Now, let's talk first about the easiest one in the book, the y-intercept, right? Now, when referring to real-world scenarios, the y-intercept refers to how high, in essence, yes, how high is the cliff? I.e., how high are you starting off the ground?
Yeah. With a plane. Turbulence. Then we'll go to the vertex, and then they just died.
Shh.
Okay.
I.e., how high off the ground did the object start? Okay, was it on a plane? Is that where it jumped off from? If it was on a cliff, were you on the roof when you threw the baseball off to try and hit Jimmy in the head? I don't know.
Is your name Jimmy?
No.
It's Kai.
Yes. Okay, but that's basically it. All right, very easy, simplistic. Now, the vertex, on the other hand, tells us a bit more information than just that. Okay?
School hazard.
Shh. The x value refers to when is the object at max height. Okay? The y value, very good. The y value refers to how high the object gets. Or how high does, oh, the y-axis. Okay, there you go. All right, now, the x value, we can calculate the vertex, if you remember, of the x value using a simple equation. Okay, and that equation was x equals the opposite of b over 2a. Okay. And that is found, I'm going to put something behind this because I keep poking holes in it. Stand by 1 second. Thank you. There we go. That's better. Okay. And that is found, when that is found, we plug it into f of x. F of being the function and x being the time at which the max value is. That gives us our vertex point, which we've been doing now for several other sections and weeks, right? Nothing really new. We're just applying some concepts and words in real world to it. Okay? And that's pretty much it for the upper part of the graph. Now, let's talk about the lower portion. All dismiss. Well, I need to be able to see those boxes.
What is the x thing? X equals what?
Negative
b over 2a. Negative b over 2a and f of x. Okay. All right. Now, down here, here's a question for you. Can you have such a thing? Now, obviously, we've talked about over here. The x values are in terms of time, when. So the x-axis is time. The y-axis is then height. Usually in terms of feet or meters. Time will always be time. Seconds, minutes, All right. Now that means that, can we have such a thing as a negative time? No, you cannot. So this 0 gets thrown out for being too negative. Okay, we don't care about the left side. Get rid of it. Poof, gone. We only care about the stopping point when it comes to zeros and the x-axis. And at this point, at this positive 0, there's 2 questions you need to ask, or you will be asked. When does the object hit the ground? The other was, how long is the object in the air? And those are 2 questions. Okay, I'll leave that up for a second.
That's what I'm gonna read. It's just like the rain. 1 minute is hard.
Now, finally, we're going to talk about the last box up here. So, the main thing about all this is, 1, how high is the object after x seconds is one question you're going to be asked. And in order to figure that out, you plug in the given time in seconds into the graph's equation. Now, let's talk about applying this into the actual real world. Well, let's say I'm given a set of parameters here, okay, or set of situations. The first one we're going to talk about at the top here, at number 1, is a punter kicked the football into the air with an upward velocity, we'll talk about this word here in a second, of 62 feet per second. Okay, we got a number right there. Its height in h in feet after t seconds is given by the function as follows right here. Okay?
Yep.
This is A, B, and C, obviously. Now, when it comes to talk about the velocity, the only thing I really want you guys to worry about at this point, and you'll learn about this more when you get into science, you take physics, or if you take pre-calc or pre-calculus road or calculus, is you will learn basically what each of these numbers are, how to calculate them, how to find them, etc. But right now, I just want you to associate the correct portions of each. The number in the front, negative 16, is acceleration. I'm going to do ACCEL for short. 62 is velocity. I'm going to do VECOL. That's an O, sorry. And finally, 2 is equal to position. Okay? Or the starting point, basically. Okay? Those are what those 3 things mean. And that's all you need to know about that. Okay, again, negative 16 equals accel, which is short for acceleration. 62 equals velocity, or VECOL, VECOL. And finally, 2 is position, or the starting point, in parentheses. Okay? Now, with all of that said and done, all right, we can then use this information to calculate for values. Like, let's say, again, we take the equation x equals opposite of b over 2a. We're going to plug that in. So we have opposite of b, which is negative 62, divided by 2 times negative 16. That then gives me negative 62 over negative 32. That reduces, we can pull 2 out of both of those numbers, and I get 31 over 16, which becomes the decimal 1.9375 seconds. However, typically, when we round significant figures or significant figures or significant digits, basically, the amount of places after a number, okay, usually it will tell you. Usually you use the smallest given number. Since we weren't given a number, we just can decide what we want. Typically for my papers, I require you guys to always round the 3 significant digits, i.e. to the 3rd decimal place right here. You're going to cut that off. So your actual answer for B, not A, because we want to know how long it takes for the ball to reach the maximum height. We're finding the x coordinate, obviously, of the vertex. That's the maximum height, as referred to on here, right?
Wow.
Okay, so that would round then, and you use 2 little squiggly lines, like an equal sign with a squiggly, and you do 1.938 seconds. And that is the answer I want. Okay? Whoops. Now, the next thing is we need to find out what the maximum height of the ball is. Well, all we got to do is take this number and plug it into this equation. All right? So what we're basically asking is, what is f of 1.938 equal to? Well, we break out our handy-dandy calculator. Okay? We'll talk about that one later. Negative 16 parentheses 1.938 close quantity squared. So you're basically plugging in the equation. And hit enter, and there you go. So your answer is 62.062496. But again, we want the 3rd decimal place. 1, 2, 3. So again, if you need to do the little waves there, cut it off. It doesn't round up. So the answer, after 2 little equal squiggly signs, is 62.062 feet. And the other one was seconds. Yeah, I labeled it. Okay, don't forget the label. Okay? Another thing, by the way, is, and now granted, I will give you the units, but if you're ever taking a test and they don't tell you what the units are for something, just write down, for your final answer, do point something something units. Just write the word units. It is at least defining it as a scalable value, meaning, as a measured value of some kind. Okay? It's kind of like the emergency panic button if you can't figure out what it is. Usually they'll tell you, but there are some rare cases where people will forget to ask for it, or they won't define it, or you know how to do all the math behind it, but you don't know what unit it is. Well, just call it units. Unit squared, all that kind of stuff, okay? Now, with all that, the last thing we have to ask ourselves is, how long does it take for the ball to hit the ground? This basically is asking for the x-intercept, right? On the positive, the right side. So we can't factor this thing. We can graph it, though, and find it. Now, if we go to graph, yeah, you got negative 16. I'm just going to punch values in because this one's like the next one we're going to talk about. 62 and 2. And you hit graph. And it gives you something really, really ugly. There's the line crossing. It does up like this. If you were to do zoom fit, you'd get a pretty arc, but it'd be really thin at the top. It doesn't look good. Okay, so it looks like this. Yeah. Not fun. Okay, but it gives you an idea, sense of scale on these things for sure. So realistically, just do zoom 6, and you can just worry about where it crosses the line over here. If it will graph.
Do graph. We'll do second table.
What happened? Oh. There it goes. Okay, zoom 6. All right. Now, next thing you can do is we need to find the 0. Now, you already know the one way to do it. You do second trace, go to 0, find the left bound of the point. Just look at the y there. Okay, I'm going to go up. So right there, come back, guess it. And there's the answer, 3.9. However, there is an easier way actually to get it, believe it or not, that doesn't involve doing 3.9 seconds. I almost forgot the label. Okay, that involves doing that crazy trace. What you can do is you go back to y equals, and you set it equal to 0. And then you go back and graph again. Then you do second trace, intersect, get as close as you can to where it crosses the x-axis. Hit enter again, hit enter again. There's your answer. So instead of doing the arrows, all you need to do is set y equal to 0. What you're basically doing is you're saying, hey, I want you to define this line as a known value, and these two technically intersect. So you're giving the axis a value that it can compare against. It's just another way of solving for the intercept, and it's not necessarily a bad way of doing it easier. So if you don't like trying to zero in on it, that's the other route you can go. Okay? Very helpful. Now, the last one I'm going to talk about, and then I want you guys to handle 3, 4, and 5 on your own, because 4 and 5 essentially is just a repeat of what we were doing almost on the test. Don't worry about that. And 3 is basically a repeat of 1, just with some different numbers in it. But we're going to talk about 2 because C is asking a very specific question that we need to discuss. All right, so firstly, let's go ahead and identify what we know. Let's go ahead and calculate out. So we know we've got a velocity of 20 feet per second. We know feet is in F, T is in time. Here's our function. Great. So let's go ahead and figure out what the opposite, or x equals the opposite of b over 2a would be. Yep, negative 20 over 2 times negative 16, which gives me negative 20 over 32, negative 32, sorry, which gives me a positive value of 0.625. Look at that. It's already in 3 digits, whatever. Okay, so that means that we got 0.625. Whoops, that's in the wrong line. Rats. I'm out of whiteout. I got to find one. Oh, wait, there's only one in here. I had 2. Okay, that was the wrong line. 0.625 seconds. So we're going to take this number, plug it into here. So we then have, and I don't mind, you can actually write h of t. If you want to do it that way, you can actually do that. That's perfectly fine. Doesn't really matter to me. Okay? Or you can do f of t. But realistically, it should be f. There's a typo on this one. This should be actually f because it defined height in f, not in h. Okay, so f of t being f of t is 0.625. So we're going to plug that into the function. So negative 16, 0.625 squared plus 20 times 0.625 plus 6. So go ahead and get out of here. So we do negative 16 times 0.625 quantity squared plus 20 times 0.625 plus 6. And we get, something's not right. Oh, I had a massive typo last block. Whoops. Okay. Well, the answer should be 12.25 feet. And there's your answer for that one. Okay. Finally, C, on the other hand, asks a very specific question. How long does it take for the disc to be caught at 3 feet off the ground? It's not asking for when it hits the ground. It's asking for 3 feet before it hits the ground. There are 2 ways to consider this problem. From a graphical perspective, you could basically go to where x equals 3, and there's your answer. Okay? On a calculation perspective, you'll need to set this equal to 3 and get it to the other side and solve and then factor it. Or plug it in. So you have 2 ways to solve it. So let's do the way that involves solving it using mathematics, at least that way. 3 equals negative 16 t squared plus 20t plus 6. So we're going to subtract 3 from both sides. Right? So then we end up getting 0 equals negative 16t squared plus 20t plus 3. Okay? That is what we're going to graph. So if we go into here, y equals negative 16x quantity squared plus 20x plus 3, second graph, whoops. Okay, again, I'm going to use the zero intersect trick. Second trace. The intersect trick, there we go. Get close, enter, enter, enter. So I get roughly 1.385 seconds. Now, had you wanted to do this from a graphical perspective, what you would do is you'd plug in the original function, which was basically just plus 6. You would then go to table, ignore the y column over here, and, oh wait, no. Yeah, okay, my bad, no. So you basically would have to plug in, and on the calculator, I can't remember how to do it off the top of my head, but on here, you basically would plug in x equals 3, and would basically graph the horizontal line, and then you'd find the intersection there. That would then give you your answer. But we can't do that because we can't graph in a graphic. Now, in Desmos, you could do it, but if we can find the height at 3, right? Think about that. We go over to the, that amount of time, or up to that amount of seconds, we go over and we get the line there. There you go. That makes sense to everybody, what I'm trying to say there? So you can kind of graphically see what's going on. I think actually, wait, maybe I can't do it. Let's experiment. Hold on. Let's plug that in for 3, and then we hit graph. Because technically, we're just talking about when it crosses the line. All right, let's find out. Second intersect. Let's see if we get the same answer. I'm curious. It should. If it doesn't, then I'm wrong. But you should hypothetically get the same thing. Yep, there it is. So if you plugged in the new ground, if you want to call it that, we're basically, translating the horizontal line up, and there's your crossing point. So you've got multiple ways to solve these. All right? Just comes down to whatever you're comfortable with. All right?
I think I got it pretty flat.
All right. Okay, so the last one, number 3. We're going to do this one again together. All right? Number 3, again, same procedure as before. First step, let's find out what that max height time is. So we've got x equals, I almost forgot. Height's in h this time. Whoops, wrong color. T is in time. We've given the function here, and our velocity is 46. Okay, so we've got to find the equation first. So it'll be negative 46, opposite of b, over 2 times a, which was negative 16. That gives me negative 46 over negative 32, which is going to reduce down to, or can be simplified to, 1.4375. Cutoff is right here. Round it. Yep, 1.438.
Yeah.
So the maximum height time is 1.438 seconds. Okay? Very good. We take that number, we plug it into our function originally. So we have negative 16 times 1.438 quantity squared plus 46 times 1.438 plus 6. Okay? I come over here to handy dandy calculator and plug that whole sucker in. Oh, the light on this thing is just terrible. Hold on. There we go. Okay. So I'm just going to come back up here and grab this and make some modifications. Make this 46 right here, and I'm good to go. All right. So then I'm just going to replace the numbers inside. I've got 1.43, whoops, 8. There we go. 1.438. Okay, and hit enter. So my answer will be a height of 39.062 feet. Okay. And of course, finally, how long does it take for the ball to hit the ground? So again, you can basically graph that in the graph. So y equals, clear it out. So negative 16 x quantity squared plus 46x plus 6. Put 0 in for the other one. We'll do the intersect trick. Graph it. There it is. Second trace. intersection. Close enough. And there it is. Answer is 3 seconds. Okay. And there you go. All right, so hopefully you guys at home found that helpful.